This screencast gives an example using the Jupyter Notebook and XArray to analyze gridded data that comes from atmospheric or oceanographic data sets. We're going to use XArray to load up a NetCDF dataset that has a single data variable, the sea surface temperature, that is a three-dimensional grid along dimensions time, latitude, and longitude. XArray follows sort of standard pandas indexing. We can look at, say, the time coordinate. We can do things like compute the minimum of that time coordinate. So XArray uses NumPy and pandas and has some of the API from both, but it mixes them to great effect. So as an example, to show some of the differences from pandas, let's compute the average of the sea surface temperature over time and plot that. We see here that what was stored was not a single record of a data frame, but it was set in an image. So XArray handles n-dimensional data structures, such as you might find in images or movies or higher dimensional structures. XArray provides a number of semantic indexing. So instead of indexing, I want the fifth row and the 10th column, you can index with values like the year 2000 and the year 2016. Instead of averaging across dimensions like dimension 0, dimension 1, dimensions are named. I want to average across longitude and take the subtract off the average that's spatial. This is a nice plot that shows the sea level, the sea temperature as a function of time in both the northern and southern hemispheres. And you can see that they're sort of shifted off from each other. So this provides an efficient query language for scientists to use to construct complex plots. Internally, XArray just stores this data as NumPy arrays, which are doing all the real computation. So here the sea surface temperatures is a NumPy array, the three-dimensional NumPy array of float 32s, and it's just regularly gridded data.